Good day, everyone. Welcome to my poster presentation. This is Muhammad Imam Hussain from the Laboratory of Soil Conservation, Graduate School of Agriculture, Hokkaido University, Japan. The title of my poster is Precise Estimation of Dodecyl Benzene Sulfonate (DBS) concentration from DBS DUM complex solution using UV spectrometry. First of all, we would like to know about the DVS. It is a very common anionic surfactant and vital agent in the component of most cleaning activity like soap, detergent, shampoos for industries and commercial household everywhere. Therefore, billions of liters of DVS are releasing in the natural water bodies from our daily cleaning activities. And it is destroying our cells, imbalancing our natural ecosystem because it is harmful to the organisms, animals, soils, and higher plants also. So therefore, precise estimation of DVS is very essential for understanding its absorption in soils, transport, toxicity, and fate, of course. Conventionally, DVS is identified using the UV spectrometry, using the benzene ring of DVS. But the similar benzene group components also present in the dissolved organic matter. And therefore, in conventional spectrometry, when we measure a DVS solution from natural source like the soil water, so it gives the excess quantity of DVS reading because dissolved organic matter also has the benzene ring and it also absorbing in the spectrometric process. So it is necessary to measure the influence of dissolved organic matter portion and sidestep its influence to precisely measure the DVS from a DVS DUM complex solution. And hypothesis, as we know that DVS can absorb the UV light, like in our experiment, we used a 2 to 2.5 nanometer. And dissolved organic matter also absorbs the same wavelength. But in visible light, dissolved organic matter absorbs the visible light because it has the turbidity or opacity in different level. But DVS solution is transparent and doesn't absorbs the visible light. So from this type of phenomena, maybe we can develop a precise DVS measurement method using the spectrophotometer. Our objective is this actually, to propose a precise spectrometric measurement of DVS concentration from the solutions containing dissolved organic matter at pH 5, 6, and 12.5. In materials and methods, first of all, we extracted the dissolved organic matter using the 1 millimole and 100 millimole per liter sodium chloride solution at pH 6 and 5 respectively. And we extracted the dissolved organic matter in the form of dissolved solids. And after that, we prepared the dissolved organic matter and DVS complex solution using the previously extracted dissolved solid solution as the solvent. And we prepared 0, 50, and 500 micromole per liter DVS solution. And 10% sodium hydroxide was also added in all replicates to measure the higher pH condition like 12.5 pH. And DS solutions concentration also we measured using an oven dry process. And before the spectrometry, we diluted all triplicates 10 times. So therefore, the sodium chloride concentration becomes 0.1 and 10 millimole per liter, and the DVS concentration became 0, 5, and 50 micromole per liter. Now come to the result and discussion. First of all, we'll discuss about the dissolved solid concentration in relation to the UV and UV visible absorbances. In figure 4a, we see in the x-axis dissolved solid concentration with milligram per liter unit, and in the y-axis, this is UV visible absorbance at 400 nanometer. So this longer line is for the 0.1 millimole per liter sodium chloride condition, and this is smaller for the 10 millimole per liter sodium chloride conditions. And there are three concentration of DVS: 0, 5, and 50 micromole per liter. But interestingly, we see here with the increase of dissolved solid concentration from 0 to 40, the increase in the 400 nanometer absorbance we noticed, like here and here is increased. But with the increase of the DVS concentration, there is no change in the absorbance values. I mean, all three lines stays on each other. In figure 4b, we compare here dissolved solid concentration in x-axis and with the absorbance at 2 to 2.5 nanometer ultraviolet spectrum in y-axis, the absorbance. So unlikely to the previous picture, in this graph, we see because of the difference in DVS concentration, they just gives the different level of absorbance at 2 to 2.5 nanometer spectrum. Yes, of course, both of the absorbance has the impact because of dissolved solid concentration, but this UV absorbance has the reflection of the DVS concentration here. And after that, we compared these two absorbance here. In x-axis, this is 400 nanometer absorbance, and y-axis there is UV 2 to 2.5 nanometer absorbance. And from this relationship, we get very straightforward and very strongly positive regression relation. They well correlated with each other. And that's how we can propose a regression model like figure 5. In figure 5, we just keep the x-axis with 400 nanometer absorbance, and similar to the figure 4c, also here we keep the absorbance at 2 to 2.5 nanometer in y-axis. So what we see here, if we plot the DBS free only DUM solution, so it will be like this line. And if we plot the absorbance of DVS DUM complex solution, it will go through like this line. So from this relationship, we section it. So this area, this portion only represent the absorbance of UV 2 to 2.5 nanometer spectrum only because of the dissolved organic matter. And this whole area, this area represent the absorbance because of DVS and DUM together. Therefore, we can see this middle part, this portion only represent the absorbance of DVS in 2 to 2.5 nanometer. So using this phenomenon and relationship, we can develop a mathematical formula like this. This formulation, we go through the equation 1, 2, 3, 4, and 5. All details are in my poster. So ultimately, in finally, we develop this equation, the mathematical formula. So using this formula, we can eliminate the influence of dissolved organic matter in the solution of DUM and DVS complex solution. And we can measure the DVS very precisely, eliminating the influence of DUM. So in figure 6 and 7, we will show you the result. In figure 6a and 6b, it is the relationship between the actual DVS concentration we added to the solution and the conventionally measured DVS concentration, what we found. So 6b for the 10 millimole per liter sodium chloride condition, and 6a for the 0.1 millimole per liter sodium chloride condition. So in figure 6a, we see this blue dotted line is the standard DVS line. And because of the higher and higher dissolved solid concentration, the conventionally measured DVS concentration just increase here. As the increase we see in the DS solution, DS concentration, so it's also increase the DVS concentration here. And with the maximum dissolved solid concentration, it shows the maximum DVS concentration. With the less dissolved solid concentration, like 14, it shows the little less DVS concentration, while the real DVS concentration represent only this line. So when we applied our relationship we developed in this mathematical model and applied here to remove this influence of dissolved organic matter in the spectrometric measurement of DVS, we found this type of graph like figure 7a. So in x-axis, it is the actual DVS concentration, and in the y-axis, there is the calculated DVS concentration. Here we see, even if there are some dissolved solid concentrations, but using our model, we successfully eliminated the dissolved organic matter influence on the spectrometry, and it shows the exactly the same DVS concentration what initially added to the DVS DOM complex solution in the preparation stage. So, and the same result also we get from the 10 millimole per liter sodium chloride with pH 5. So in conclusion, we actually propose this. We stated about our method. This is very rapid and it requires no reagents, and it only measures the two absorbance using the spectrometry, and no special reagents is not necessary, and it's very simple also and very precise method for the measuring the DVS. Thank you everyone for your kind watching of my presentation. I'd be so glad if you leave some comment or question in the comment box. Thank you again.